Good evening. My name is Robert Olson. I am the Chief Engineer for the Controls Department for the CSUN. I'm in charge of the brake system, the shifting the clutch, and the electronics. To my right is Rio de los Santos, who is in charge of the pedal assembly and the throttle linkage. So to start out, what's the point of a controls department? This is to allow, through driver input, the ability to slow or stop the motion of the vehicle, to accelerate the vehicle, to be able to shift the gears, to be able to disengage and engage the clutch, and also manage and monitor the engine vital functions. The department goals we have for this year are to implement an adjustable pedal system, utilize the Motec ECU to its full advantages, clean up the wiring and the plumbing inside the cockpit of the car, and maintain previous designs from previous years as much as possible. So to start out, I'd like to talk about the braking system. Now, what is the point of a braking system? That's to slow or stop a vehicle safely and reliably. And this is done by converting kinetic energy, motion, into thermal energy, heat. So the two systems we looked at are a hydraulic disc brake system and a hydraulic drum brake system. Now, obviously, the industry standard today is a disc brake system. It offers superior cooling properties, lighter weight, and is resistant to brake fade as compared to the drum brake system. The components of a disc brake system include the calipers, the rotors, master cylinders, fluid reservoirs, brake pads, and balance motors. So to start out, talk about the calipers. There are two major design concepts for the calipers. There's fixed and floating. The floating calipers were designed by car manufacturers to reduce the cost of manufacturing calipers. What they do is they eliminate a piston on one side of the car, or one side of the caliper, and through this, the calipers actually move axially on pins within the caliper to slow down the car. And this allows the caliper to self-center itself under braking in case there's any misalignment between the caliper and the rotor. And this will prevent any vibrations from going through the car if this happens. And the fixed caliper obviously has two pistons on either side, and these are mounted two different ways. The regular, which obviously has the mounting bolts pointing perpendicularly to the face of the rotor, and also a new style which is coming out is a radial style mounting bracket, which has the mounting bolts parallel to the rotor, to the face of the rotors. And two designs for this include the monoblock design, or a two-piece design. Some of the features of these include monoblocks can have creative designs. However, they can be difficult to manufacture as they come from one piece of material, and they can be rather difficult to service. The two-piece design, the manufacturing and assembly is greatly simplified compared to a monoblock design, and the steel bolts in the bridge that connect the two halves together can offer increased strength to the caliper. And the materials you'll find calipers made out of today include cast iron, aluminum, steel, and metal matrix composites. And for the rotors, again, there's two different concepts for rotors. There's fixed and there's floating. Much like the calipers, the floating rotors allow the rotors to move axially on the hubs, and again, this prevents vibrations from occurring. And they include solid, grooved, cross-drilled, dual ventilated, or combinations of each. Solid rotors are mainly designed for light-duty use. Groove rotors, the grooves allow spent gases from escaping between the pads when they build up, and they also allow the pads to bite more onto the rotor, allowing for more friction. Cross-drilled rotors, they allow air to travel in between the holes to provide superior cooling, and again allow the pads to grab on more of the rotor to provide better breathing. Dual ventilated are two rotors sandwiched together with vanes in between them, and that again provides superior cooling properties for the rotor to cool down faster. The two master cylinder designs we looked at this year include a solid mount from the 07 car and a tilting design from last year's car. Some of the features of the solid mount include they have integrated reservoirs into the actual master cylinders. This provides a rigid mount for this. However, it can be rather bulky and take up quite a lot of space within the cockpit of the car. The tilting design used last year was very compact, it was lightweight, and it allowed the use of remote mounted reservoirs, which is what we'll need to do for implementing a adjustable pedal system. balance bar is defined as an adjustable lever that pivots on a spherical bearing. We integrate this to the pedal. It provides a mounting point for the master cylinders, and this also will allow better balancing, or allow for accurate balancing of the force applied to the front and rear master cylinders that we can tune. So for this year's brake system, we propose to use this brake system with floating rotors on all four corners. We'd like to make them out of steel. They will be cross-drilled. We would like to use fixed aluminum calipers, and we would like to use a tilting master cylinder design and implement that on top of our floor-mounted adjustable aluminum pedal system. So I'd like to hand it over to Rio.
Good evening. I'm Rio Dos Santos, and I'm the throttle engineer for this year's team. So here are my objectives for tonight. First, I'm going to give an overview of the components and the purpose of the throttle controls. Then I'll state my goals for this year before giving a component discussion of each part. Finally, I'll give the design proposal for this year. So starting off with my first objective. The throttle system is made out of the gas pedal, the control cable, and the throttle body. These components, along with driver input, work to control the amount of air flowing into the intakes, and thereby indirectly controlling the amount of fuel that's burned in the engine. Excuse me. And because vehicle performance is a function of driver skill, issues such as ergonomics, driver feedback, and reliability must be kept in mind during the design of the throttle system in order to facilitate and hopefully make the job easier on the driver. So at that note, here are my goals for this year. To employ adjustable pedals, allow adjustable cable sensitivity to optimize pedal output, to be reliable, and to be as lightweight as possible. So the first component is the pedal. The pedal can be of two constructions. The first is the 4-bar linkage, as you can see in the image. It provides adjustable cable sensitivity. However, it has more parts manufactured and therefore adds weight to the system. The compact assembly is much simpler in design. It's lighter and requires fewer parts to manufacture. However, cable sensitivity, it does not allow for cable sensitivity adjustment. Excuse me. Now the pedals can be made of either aluminum or carbon fiber. Aluminum has been the material of choice for the past years because of its lightweight and ease of manufacturing. Now the material is carbon fiber. It is lightweight, it's different than aluminum. However, it requires longer manufacturing time. In fact, 2 years ago reported about 2 weeks of manufacturing time.